Hello, hopefully all of you are doing good. Now we were discussing with the prolog list, right? So let us continue continue our journey, and let us try to see what else we can do with the prolog list. So in the previous video we talked about how to concatenate two lists in prolog, right? So in this particular video let us try to see how we can add or delete element from a prolog list. So we'll start with a very simple use case for add, then probably we'll see the delete one as well. So let us first try to understand the concept, then probably writing that prolog clauses will be very much easier from there. So as I said, first we will talk about how to add an element to a prolog list, correct? So let's say I have a prolog list L1 which have an existing element called, let's say, B, C and D. Okay, now I need to add another element, let's say A, to this prolog list here. Now as a very simple use case, I can try to add A at the beginning of the list, because we know the pipe operator, right, which separates the list as head and tail. So adding this element A to the head of the list will be very much easy, right? So we can write, even we do not need any procedure as well, we can directly write something like A pipe L1 inside a square bracket, which will basically create another list for which the A is the head and rest of the element like the tail is basically my L1 over here. So the final list will be something like this one, right? A comma B comma C comma D here. So this is pretty much easy. Even if we want to write a procedure, we can create a procedure called add, right? So let us try to do that in a prolog program over here. So whatever we have seen for the add, we can basically develop a clause called add over here. Okay, so which will basically take two lists and it will basically output another list which will have the initial input. Let's say I have an input called X here, okay, which is a variable over here, and another list, let's say L over here. Now there will be the third argument of the list which will basically tell us what is. So if I just add X as a head and L, this guy L as a tail of a new list, what that particular new list will look like, right? So that means the new list will look like something like this one, X pipe L over here, right? So this will be my simplest clause to add an element to the head of the list. So if I just try to test it out, this guy, so I can make it, I can consult this particular selection here. Okay, so now if I just try to do something like this one, add, so let's say I want to add A, an atom, right, to a list called B comma C comma D here, right? So this is the one, and here also as a third argument I will provide, let's say, another variable which will basically hold the full list here after I add A to the head of this particular Y over here, right? So this works in a very basic scenario, but if I want to add A to any of this other position, this one may not work over here, right? So in that case we have to think about what could be the other possible solution, but this could be a very simplistic solution over here. Now let us first try to discuss the delete stuff, then we will try to see if we can use that one some way to achieve this guy, like if I want to add A to any of this position over here. And if I just follow the simple thought process we have done in previous videos as well, when we were developing this particular predicate, right? This particular predicate over here, we started with a very simple stuff in mind. We basically, if we just forget about variables, if everything is a atom or some non-variable term over here. So basically what we are trying to see is like the third list we are providing over here, whether X is the head of that list and L is the tail of that list or not. That is what exactly we are trying to find it out over here, right? So once we did that, we can pass Y as a third argument here, which will basically give me the full list over here, right? So the thought process is also important over here. That's why I'm just pointing it out. Now let's move to the delete operation. Now let's say we are talking about the delete operation here, right? So let's say I have a list L, which is something like this one here, A, B, C and D here, right? Now I want to delete an element. Now there could be two scenarios over here, right? Either I want to delete from the very first element here, like either I want to delete the very first element, or I can delete some of the items from the tail of the list as well, right? So this is basically my head of the list and this is basically my tail of the list. So either I can delete A or I can delete any of the items from B, C and D here. So two scenarios occurs over here. So that means we need at least the two clauses to support that. Now if you see it here, if I just want to delete the first element, what will be my output? So let's say from L, if I just delete the first element, my output will be L1. Let's say it is B comma C comma D here, right? Without the first element over here. That means tail of the list. So I can have a clause something like this one. Let's say I'll give it a name called del. Okay, so here also the first argument will be the element I want to delete. Let's say I'll give it a name called variable with this one, X over here. Now the second argument would be the list from where I want to delete that one. Okay, so this will be my list over here. We need to write something. And the third argument will be the final output list over here, right? So this will be another list over here. So let's do this one. So if I just create a fact something like this one, so X is, I'm talking about I want to delete X from my list L over here, right? So if I just write L something like this one, X pipe, let's say L T, just to mention like it is the tail of the list L over here. Okay, so if I write like this one, my input list L, what would be my output? Okay, now here also the thought process is important. So what I am trying to achieve over here is my third argument, whatever it is, it should be same as the tail of the list L over here, right? Then only I can say my X has been deleted from the first element of the list, right? So if I just write L T here, so that will serve my purpose, right? So basically what I am saying is my input list, if I just can output a tail of that list, so that is sufficient for me to say I have actually deleted the first element of the list. Now in actual query, I will be using some variable name over here to get that what would be the elements over here, right? So let us see this one first. So if I create the clause something like delete, then X comma inside square bracket I will write X pipe L underscore T. Okay, let's do this like this one. Now what will be my third argument? My third argument will be the same L underscore T I have created over here, right? So this will be my, so if I just make a fact like this one, so this will be enough to delete the first element of the list. If I just try to see it and consult selection, so now if I just say delete A from the list A comma B comma C here, okay, and let's say output list, I'll give some name called L1 over here. It's a variable. Okay, so if I just use that, so this will, the output list L1 will be B comma C here, because that is what we have written it over there, right? So fair enough, but how I can delete something from the tail of the list? So let us try to reason through that one as well. Now to delete something from the tail of the list, let's say I want to delete C. What we can do is we can basically loop through it, right? Loop through element by element from the tail of the list, and then see whether that particular element is matching with the one we want to delete it. We want to be deleted, right? So then we can basically ignore that element over there. So we can write something like this one. So let's say, so as looping through is required, so we already did it multiple times. So we will be basically creating a recursive rule over here, and we will be using the same del one, right? So I can write something like del, which the same thing I have written it over here. So I want to delete X from a list, something like this one, and I want to output another list over here, which will basically ignore that particular X over here. Okay, and as we want to loop through it, right? So that means we have to create a recursive expression. That means there will be another del, and we will be passing the similar kind of first element as some Prolog object, and second two elements will be list as well, correct? The second two elements are list as well over here. We will see how to do it. Okay, so this will be the one. So generally when we want to loop through it, we pass the tail of that list over there as well, which we did it multiple times as well in the previous videos, correct? So let us try to reason through it now. So let's say I have the similar L over here, and I want to delete the C here, right? So which is basically belongs to the tail of the list L over here. So if I write something like this one, so instead of X, because I already have a fact something like this one, so if X is the head of the list, so I already know how to delete that one, right? So I already know that one. Now if X is not the head of the list, so let's say if I am inputting X over here, which is not basically the head, that means I will be using a separate variable, let's say Y, and L of T over here. Okay, so that is the input list tail over here, and let us first write it down, then we will reason through it. And I am writing the same Y, whatever variable we have used it over here, and then let's say L1, this is the output of the list over here, the output list over here, tail of the list. So what we are basically doing it over here, if you see it, like we have used the pipe operator to know whether the first element of the list are basically head of the list are same or not. Because okay, now the third process, if I just come back to this one, so basically what we are trying to achieve it, what we are trying to write it over here is we want to delete something from the tail of the list over here. So that means the head of the main list and the head of the output list will be same. That is what this Y is taking it over here, right? So if I just write the example L, that is what we have, A, B, C and D, and this is the input list, right? And L1 is my output list. I want to delete the element C here, so that means A, B and D will be my expected output over here. So what this clause is telling me, the head portions are same, and then we are basically looping through all the elements over here and checking whether this is also same as this is, right? Now when it comes to C, because L has C, even L1, when Prolog will be checking the C over here, I'm just writing it's very small way because ultimately it will be deleted. This one will be taken care by this particular clause over here, right? So we know if the head of that list we know something to delete from the head of the list over here, right? So that's why the C will be deleted over here. Again, the same checking will be done over here, like whether the rest of the tails head is same or not. And as we are looping through it, so what will pass over here? We will pass this to tail portion over here, right? So let me write it down. We need to basically remove these brackets over here. So just like we did in previous video as well, to loop through it, we will be passing the tail portion over here, L1T over here, which will basically loop through it, and it will check whether the element wise first element of L is same as the first element of L1 or not. It will continuously doing that. Once it is find the element which it wants to delete, it will basically use the first operator to do that one. Then it will continue to do that one. Okay. Now let us try to write it down and see whether it works or not. So as we discussed, we will write something like this one, del, right? The first element is X, which we want to delete. The second element will be as we discuss. So you will basically loop through the L and L1 and try to delete that element, right? So let's say L underscore T here. So that's my first list. My third list, similar way I will be doing it. And as I will be checking the same element over here for L and L1, that's how I am using the same variable name over here. And then L1 underscore T here. Okay, and just to loop it through, we will be using the recursive way of definition over here. So that means I'll be passing X over here and this to tail portion over here, right? L underscore T and L1 underscore T here. That's it, right? So we already discussed the recursive way of defining this one, right? I think we need a bracket over here. Let us do that. Yeah, so this is fine. So now I can make it, and let's consult this. Okay, so now we have defined our del one, right? So we can post some queries over here and try to see whether it's working or not. So let's say if I am posting a query something like this one. So I am trying to delete B from this particular list, and if you see it, like B belongs to the tail of the list, and my output I am expecting A and C. There is no variable involved over here, so that means Prolog will basically answer me with true and false. Straightforward, right? It is able to know, yes, we are able to delete B, and that means the output list should be A and C over here, right? The A is matching with A. When it finds B, it is basically using the first fact to delete that one, and then similar it is moving on. Now let's say another example. Now instead of giving the list, hard-coded list over here, we can pass a variable to know whether it's basically what is the output over here, to generate the output over here. So this time Prolog will giving me output over here. Now what will happen, let's think about this one. If a particular element I want to delete over here basically exists multiple times in that list, something like this one over here, right? So if I post this query, Prolog will actually giving me, because of the backtracking, Prolog will actually giving me all the different possible combinations over here. So L could be BAA after deleting A over here, right? Now if I just move on, it could be ABA as well. If I move on, there is a 2ABA, right? Because there are two elements with the same, basically three elements with the same name A over here. So that's why it is giving me ABA, this combination twice over here. Okay. So this is how it will basically tell me this one. And with a similar concept, if I just want to delete something which is not a part of the list, Prolog will just simply giving me false over here, because nothing will be satisfied. None of the clauses will be satisfied over there, right? Now think about this one. What will be the output of this particular query? So basically what we are trying to find it over here is, if you see it here, the input list, I have used a variable over here. That means I want to know the input list. So, and this is my output list 1, 2, 3. That means I am basically trying to find a list where after deleting an element A from that list, I got the output list 1, 2, 3 here, right? So if I just post this query over here, Prolog will backtrack and it will basically give me all the possible list over here, because A could be anywhere in that list over here, because the clauses we have defined it here. So if I just see it, because of the second clause, we are actually it is basically enabling me to delete an element from anywhere of the list, right? So that means Prolog will be backtracking it and it will basically giving me all the possible combination of the lists where A is an element over here. So this is one of the one where A belongs to the head of the list, right? So now this is another one where A belongs to the second element of the list. This is another one where A belongs to the third element, and this is the fourth element of the list where A belongs to there, right? So this actually triggers something else here. If you see it, when you talk about adding an element to the list, right? So initially we talked about how to add an element at the head of the list. Now if you just see it over here, we actually added an element at any places, element basically A at any places of the list, because this is the output I have generated over here, right? So that means using the del, I can actually generate, using this one I actually add or basically define another add, which basically adds any element to the any place of the list over here, something like this one. So let's give it a name called add underscore any. Okay, now if I just write, I want to add the element X to a list called L, right? Now, which will basically generate a new list called L underscore N over here. Let's say L underscore N defines new list over here. So how I can achieve that using del? So I can write something like del X, right? Now here, so to get the actual list, so what I have to do, I have to basically swipe, right? So L underscore N will be here and my L will be here. Let us reason through it as well here. So if I just save it, so what we are doing it over here, we want to add an element. We basically want to define a new clause called add underscore any, which basically add an element to the any place of that particular list, right? And we have seen it over here. To do that, what we have to do is the final list is actually coming at the second position of the del operator, right? Of the del clause over here. So that is what I have done it. The list underscore new will be here at the second position, and my list from where basically I have deleted that X, it will come as the final position of the del. So basically what we are trying to achieve it, if I just try to tell in simple language, so we are basically trying to, at the left hand portion of the clause is basically telling me we want to add an element to the list. Right hand portion of the telling me we want to find all the list where the final list is created by deleting the element X from this guy over here, L underscore N over here, right? So let us try to see that one. Compile, make, compile, consult. Okay. So now, see if I just wanted to add any, let's say A to a list called A comma B comma C here, right? A comma B comma C here, and let's take that output as Y here. Okay, so what will be my possible combinations over here? Okay, there is a, I has given a dot over there, it should be a comma over here, right? So this could be a possible list where A is coming at the first position, right? This could be one where A is coming as the second position, Similarly, A is coming at the third position and the fourth position over here. So this is basically telling me this could be the possible lists fired, output list fired after I add A to this particular list. So this could be the possible output lists over here. Okay, so this is how we add and delete an element from a list from any position of the list over here as well. Okay, so hopefully I did not confuse you guys. See you in the next video.